Welcome to solverfy.
This problem, we're asked what happens to the volume in 4 different cases, A, B, C, and D. What happens to the volume when the pressure and temperature change? And since the problem doesn't say anything about gas escaping or being added, we're going to assume that N, the number of moles, always stays the same. So looking at our ideal gas law, we just need to make sure it always balances. Now this problem seems pretty straightforward because generally pressure is either going up or down by 2. So it's either doubling or halving. And the temperature seems to do the same, but here's the thing. In the problem, it gives all of the units for temperature as Celsius, and we don't want to use Celsius because that's not what the universal gas constant is in, and because it's relative for pretty much anything scientific. We need it to be in Kelvin. If we do that, you'll find that rather than the temperature doubling or halving, in most cases it's going down by a smaller amount. What do I mean by this? Well, the conversion between these is one of the easiest. You just need to add 273 to the degree Celsius and you'll have it in Kelvin. So how does that change? Let's look at the first problem, where the pressure is going from 2 atmospheres to 1 atmosphere. Now, if we convert the temperature, we find that instead of it is actually going from 473 Kelvin to 370. Excuse me. I wrote it wrong. To 373 Kelvin. So, first let's just consider pressure. So it's going down, which normally would cause the volume to go up. But we also have temperature going down, but it's not going down by as much. So maybe we'll just say that while the volume's increasing, it's not as much as if the temperature was constant. So in this case, I'll put a volume thing here. The volume's increasing. Because while the temperature is decreasing, which would balance out the equation, it's not decreasing nearly as much as the pressure's decreasing. For this next one, the pressure is going from 1 atmosphere to 3 atmospheres. So it's tripling. And it looks like the temperature's tripling too, but really it's going from 373 K to 573 K. So we have pressure tripling, which normally caused the volume to decrease by triple. Now, let's consider temperature. The temperature is increasing, but not quite as much as the pressure. So in this case, volume is still going to decrease because that's what is needed to balance out the equation. Now let's look at this next part. This is one where the temperature might look a little strange in Celsius. We have 3 atmospheres going to 6 atmospheres for the pressure, once again doubling. And if you do the conversion, you'll find that you have 200 Kelvin going to 400 Kelvin. So this is doubling. Let's get some color in there. So the pressure's doubling, and the temperature is actually doubling, which means volume is actually staying the same in this case. Now let's look at the last case we're asked about. We have 0.2 atmospheres going to 0.4 atmospheres. And we have and while this is increasing, the temperature is actually decreasing. If we do the math, we said it's going from 573 to 473 Kelvin. So let's look at the equation. We have this increasing, which will cause volume to decrease. But in this case, temperature is also decreasing, which forces the volume to actually decrease more. Now we're not asked necessarily about how much they're decreasing. We're not asked to solve these, so we don't need to plug anything in. But what we need to know is that volume is decreasing in this problem. Hope this helped all of you.